Hello students, I welcome you all to EPG Pathshala. My name is Dr. Aditya Tripathi. I am Assistant Professor at Department of Library Information Science, Banaras Hindu University. This is the module in which we will be talking about database management system, which is part of the paper information storage and retrieval. In this module, we will be learning about the databases and the conceptual framework of databases, how they are designed, what are all the components of the databases. Then we will be talking about the software part of databases, that is database management systems. We will be further talking about ACID properties of database management systems and different data models. In this module, we will be also discussing about database languages which are used to operate a database management system. We will be also talking finally about structured query language and some of its commands. Defining the database, a database is the large, persistent, integrated collection of data that provides some operation to describe, establish, manipulate, and access the data. If you see this definition, a database management system, if you see, it is a collection of data, okay, in which the data is described in forms of some fields, some properties. These data can be manipulated and accessed or browsed sometimes by the users. This is second definition we have taken from Chambers Science and Technology Dictionary. In this definition, as it says, database is a collection of structured data independent of any particular application. Here the term structured data is very important. As you see in the database management system, or in a database more particularly, we have records, and these records are structured. They are made up of fields, and these fields are predefined. And this kind of databases are used by different applications, or different applications can use these databases. The third definition is from Macmillan Dictionary of Information Technology. As it says, a database is a collection of interrelated data stored so that it may be accessed by users with simple user-friendly dialogues. This definition, as it suggests, that the records of databases, they are interrelated, they are sequenced, they are organized. They are organized in such a way that users can access the data, user can browse the data, user can manipulate the data through some kind of interface. This is a flow chart of a database. If you see, normally a database is a storage of data. So you will see there is a block of data which is ingested in a storage of database management as a system, or a place where data is stored. So this data is ingested in a storage place which can be retrieved in turn by different users. Okay, these users, they not only retrieve the data, they can sometimes manipulate the data, they can provide input to this system. So if you see this whole flow chart, you will find it is a kind of a cycle which we call normally as information storage and retrieval cycle. So students, we have so far seen the definitions of database. Now we will show you the conceptual framework of a database. A common table drawn on a paper is the simplest form of a database you can have. In this table, as it is represented in front of you in this present slide, you have rows and you have columns. Basically, the rows represent the records and the column represents for you the fields of a record. So in this particular representation or the slide, you can see there are 4 records and there are 6 fields. The fields are serial number, name, age, sex, post, and salary. The field serial number, which is the first field represented in the table, is a unique field, or it represents unique identification, as the numbers of this field are unique and these numbers are not repeated with any other record. That means these values of the values of these fields cannot be given with other record, and they are only and only represented with one record. So in a database, if you see, database is a collection of structured records, and each record, if you see, it represents structured data. The format of data stored in the record is predefined and uniform across all the records. That means the fields represented in the records, they are uniform across the whole database. That means all the records in the database. Say for example, if you define a database called catalog for a library, so in this catalog you define several fields like title of a book, author of a book, place of a book, publisher of a book, and so on. So these fields will remain consistent across all the records. And finally, the data is stored in these fields. That means the title of the book contains the actual title of the book. Say for example, the title of the book is Prolegomena to Library Classification. This value, Prolegomena to Library Classification, will be stored in the field called title. Say you have author as Dr. S.R. Ranganathan. So Dr. S.R. Ranganathan value will be stored in the field called author. So likewise, you store value in different fields of a record. So if you see the structure of a database, we have three parts, that is file, records and fields. A file is a collection of records. A file contains several records. In a computer, actually any data if you store, it is in a form of a file. Since as we have seen that in a database file we have several records, these records are basically group of related information, and the record is the smallest unit of information in a database. Actually, when a user accesses your database, what he accesses is the records available in the database. These records contains several fields, and these fields actually store actually store the data. Say for example, if you have a database of library books, uh, the database contains several records, and each record is about one book, and each book will have several fields like title, author and place and publisher and so on. So the values of these of the book, about its title, author and all that, these all will be stored in the fields of a record. Now let us see what is a database management system. Database management system is actually an application software which we use in our computer. A database management system, if you see, it is a computer program which is designed to manage your data in the computer. What actually it does is, it stores your information in a structured format so that you can easily read and retrieve your data from a database management system. Uh, it runs several operations which a user requests, like manipulating the data, adding the data, deleting the data, or just browsing or reading the data from the database. Actually, a database management system, if you see, it is a collection of interrelated programs that facilitate data manipulation activity. If you see a database management system, it is just not a single file. It is a collection of several files, interrelated files, which work together and perform the operation of a database management system. So we have several examples of database management system. If you see, in library science, we have CDSIS. Besides, for our general purpose data storage and retrieval, we have MySQL, we have PostgreSQL, we have MS Access, kind of database management systems which we use in our day-to-day activity. Database management systems are a kind of information retrieval system. In these systems, you can store, organize, and retrieve data as you want. These systems have certain features. If you see, the first thing is about it is data independence of a database management system. In a database management system, you can create different databases, and these databases have independent entity in the system. If you want to manipulate one database in a database management system, it won't affect the other database. So that way, whatever data you have stored, it will have independent identity. The second important feature of database management system is about efficient data access. That means you can search, retrieve, or browse database from a database management system. This data not only can be searched based on keywords, uh, this data can be browsed on different fields so that user can access the data. The third point, which is about data integrity and security. Database management system has different databases, and if you manipulate one database of a database management system, it is not going to be reflected in other databases. So your data, whatever you store in the database management system, it is not only secured, it is not going to be changed or by any unwanted method. Another thing about database management system is you can give an effective database administration on the database management system. You can define different users in a database management system. You can give them rights. You can define their roles so that they can act accordingly. You can define an administrator who can manipulate the database. You can provide permission to certain users who can view the data, but they cannot change the database. Another point is about reduced application development. Normally, in a database management system, data is stored in a structured format, a standardized format. That means if you want to develop tomorrow an application on a database management system which can fetch database, which can manipulate the database in a database management system, it is easy because the structure databases the structure of the database is standard. The structure of data storage in the database is standard. And the last thing but not the least is report generation in a database management system. See, in a database management system, normally what we do is we access the data. We access the data and sometimes we manipulate the data. But why we do all this? Because sometimes we want to generate reports from these database management system. Different kinds of reports can be generated. Say for example, if there is a system of a library catalog, okay, or library circulation. If you take another example, in a library circulation system, you can generate different kinds of reports date wise. You want to generate reports about the patrons who are borrowing a particular kind of document from the library. So different kinds of reports you can generate from database management system. Asset property is one of the very important property of any kind of database management system. It is given by Jim Gray in 1970s. Basically, ACID stands for atomicity, consistency, isolation, and durability. Basically, ACID property is used at the time of data processing and transaction of data. That means this property we use when we actually manipulate with database management system. We work on our database. That time this acid property is useful for our purpose. Reliability of any database management system primarily depends on its acid property, how it handles the acid property. Atomicity is one of the important property or the component of acid properties. We see that the transaction which is done in the database should happen in all the fields across the database, otherwise it should not happen. What it says is, if you make any change in the database management system, or you make a change in a particular field, the change should be reflected across the whole database. If at all there is a break or there is a fail in between, the system should roll back to the previous condition. That means there should not be any change. That is what it says, that transaction should be done in all the fields or nowhere in the database. The second important component of ACID property is consistency. As you know, consistency means sturdiness. In consistency, the transaction should not create inconsistencies in the database. That means when there is a transaction happening in the database, it should not create any kind of inconsistency in the database. Second point, the transaction should lead to change in the value of a field, should demonstrate changes in all the dependent fields. That means if there is a field and the value of that field is used by other fields in the database, then if you make a change in that particular field, the changes should be reflected in all the dependent fields of that particular field. In case of fail of intermediary stage of transaction, system should abort the transaction and roll back. It is more or less like using atomicity. That means when there is a transaction and in between there is a fail, or there is any kind of inconsistency, or there is any kind of mishappening, the system immediately should leave the transaction and move to the previous stage. The transaction should take place in the light of pre-laid conditions, otherwise should not take place. Pre-laid conditions are very important. Say for example, if you are doing a transaction and for that you have posed some kind of predetermined conditions, if that particular condition is fulfilled, then only transaction should take place. So when the system is performing the transaction, it should first look for the satisfaction of the predetermined condition, otherwise it should abort the transaction. Isolation is the third property uh, under ACID properties. Uh, Isolation, if you see, it is basically happens, or you can see in your day-to-day transaction when you do use e-commerce or you buy a product on different websites like Amazon or Flipkart. For one product, there may be more than one persons who would be trying to do the transaction or want to do purchase for one product. So there are concurrent transactions for one product, but what happens in the database, these all transactions are serialized. That means first transaction should happen, then only the second transaction should happen, then only the third transaction should happen. There should not be any kind of overlap among the attempt of transactions happening by different users. So this way the transaction should happen in the light of in an isolated environment, so that other transaction activity should not affect the previous one. Durability is one of the very important property of a database management system. Normally when we store data in a database management system, our idea is that data will be stored and it will be protected. So in a system, when there is a kind of any kind of mishappening with hardware, software, or maybe a kind of transactional fail, the system should immediately recover. Otherwise the condition of durability will be defeated. The second point says that each transaction should be recorded in log files or recovery files, which in turn will be utilized at the time of system failure. That means when any kind of transaction is happening on the system, there should be log file or there should be some kind of recovery files. There should be a kind of record in the system, so that we should know when what has happened in the system, and there is any kind of problem in future, we should trace back the problem in the system through log files. There are two kinds of data models through which we store data in a database management system. The first one is object-based logical models. Then the second type is record-based logical models. We will few slides we will be seeing both kinds of data models in detail. Object-based logical model. In object-based logical models, the smallest entity which has an individual existence is an object. Then an object is associated with certain characteristics and functions. That means if there is an object, each object will have certain kind of characteristics or features associated with it. And besides the characteristic, the object can have or will have ability to perform certain kind of functions. Basically, there are three kinds of object-based logical models. The first one is entity relationship model, second one is object-oriented model, and the third one is functional model. Entity relationship model. In entity relationship model, any object which is there, it is considered as an entity, and each entity has certain characteristic or which are known as attributes. Same kind of attribute is posed by, often it is posed by many entities. So what we call this group as, it is as a set of entities. Let us see different kinds of attributes used in entity relationship model. We have simple attribute as a name of a person. We have composite attribute as first name and last name of a person. That means there are two values associated with name of a person, that is first name and last name. If you take these two different fields as a composite form, it is known as composite attribute. Then we have derived attribute. Derived attribute is, say for example, age. If you know a person's date of birth, you can easily compute the age of the person. So it is basically a kind of derived attribute. You derive the value of the field through some other field. Then there is another kind of attribute, we call it as single value attribute. That means the value of this attribute is unique and same value cannot be given to any other entity in the database. Then the last one is multi-value attribute. That means for one entity, there are more than one value. Say for example, there is a book, and for this particular book there are 4 or 5 authors. So the author field is actually, it is multi-valued attribute. For example, we have different set of entities. So in different set of entities, we often find different kind of relationships. So in this particular slide, we are showing you different kinds of relationship. We have one-to-one relationship. That means there is a set called A of entities, then there is a set called B of entities, and each entity of set A is related to one entity of set B. This is a kind of one-to-one relationship. Similarly, we have one-to-many relationship. That means one entity of a set is related to many entities of set B. Then the third one is many to one relationship. It is a reverse of the previous one. That means many values of set A are related to single value of set B. Then the last one is many to many relationship. That means one entity is related to many entities of set B, and many entities of set B are also related to many entities of set A. So this kind of relationship is kind of a many to many relationship, in which many of set B elements are related to many of set B elements, so that there is a kind of relationship exists between set A and set B. This is diagrammatic representation of entity relationship model, which shows the relationship of park and there are trails associated with the park. You can see in this slide that there is one park and each park can have many trails. So there is a relationship of one to many kind of thing between park and trails. Then you will see each trail will have many features. So if you see in a group that there are trails with different kind of features and the trails with different kind of vegetation. So if you see, there is a kind of many to many relationship exists between trails and features and trails and vegetation types. It is object oriented model. In object oriented model, we have first of all object. An object is nothing but it is a kind of any kind of entity. An entity can be a computer program, or it can be a set of data. Then each object possesses certain characteristics. We call these characteristics as properties. Then we have class. A class is nothing but it is a kind of collection of objects. So when there are more than one objects with same kind of properties, we call it a class. Then a class can itself have certain attributes. It is not that the only objects will have property. The class itself can have certain attributes. So you can see the properties are not only associated with objects, the properties are also associated with class. Then we have superclass. A superclass is nothing but it is a parent class, immediate parent class of a class or an object. Then we have subclass. A subclass is nothing but it is member of a class. That means it is next in the sequence or next in the hierarchy in the class. One of the important features of object-oriented model is inheritance. Inheritance is a very important property of object-oriented model. In object-oriented model, if you see, a member class inherits all the properties of parent class. Then you will see that a member object also inherits all the properties of the class it belongs. Say for example, there is a class and there is a member of that class. That means there is an object who is the member of that particular class. The properties of the class is automatically inherited by the object. You don't have to again define the properties, same properties in the object as it inherits all the properties of the class. Then you see a member object inherits all the properties of the parent class, as I told you, falling in the hierarchy. Say for example, if there is an object and above the object there is a hierarchy of 3 or 4 levels or 5 levels. What happens? The property of the root class is also inherited by the element object of a particular class which falls in the hierarchy. This is diagrammatic representation of object-oriented model, where we have shown you patterns of library and the properties of the patterns or the attributes of the patterns. That means how many books they can borrow and so on and so forth. So you see there is a class called pattern which is represented by green block. Besides these patterns, we have certain attributes associated with this block. That means a pattern can read journal, a pattern can give requisitions, a pattern can use reprography, a pattern will have unique ID, a pattern will have name, a pattern can consult resources in the library. Now there are 3 classes under the class pattern. One is teacher, another one is research scholar, and the third one is student. So now if you see these subclasses of class pattern, the teacher can borrow 10 books, a research scholar has privilege to borrow 5 books, a student can borrow 2 books. But you see these classes can inherit all the properties of pattern. That means a student can borrow 2 books in addition to the properties posed by the class pattern. That means a student can read journals, he can give requisition, he can use reprography, he will have a unique ID, he will have a name, and he can consult resources from the library. So these properties which is posed by the class patron will be inherited by all the classes, all the subclasses of class patron, that is teacher, research scholar, and student. Functional model. This diagram represents you the functional model of a database management system. You can see different layers of a database management system. At top we have procedures. Above procedures we have different kinds of applications which can access database management system. Below the procedure, below the database management system, we have structure. That means the schema of the database. That means what are all the fields are there for the database, what are all the properties of these fields. That means they are numeric, they are alphanumeric, or what kind of values these fields do store in the database management system. This is defined at this level, which is structure level. Then at the bottom we have the content. That means the field of the database. Content actually is nothing but the value of the fields which is stored in the database. So most important is the content which is stored in the database, which is at the bottom of this given diagrammatic representation. At the top we have procedures. Above that we build all the applications for any database management system. Now we will see the record based logical models of database management system. We have three kinds of models associated with this. We have relational model, we have hierarchical model, and we have network model. In the next few slides we will see all three kinds of models in detail. Relational model. This is diagrammatic representation of a relational model showing you the circulation activity in the library. Here you will see there are three tables. The first table is about the book. You will see different fields of this table, that is book ID, title, author, place, publisher, year, and price of the document. There is another table called user table where user information is stored. We have user ID, we have name, we have address of a person, we have position held by him, and we have his contact details. So these are two primary tables we have. Now we create third table, we call it as circulation table. Actually, if we issue a book, the data is stored in circulation table. So when we store the data in the circulation table, what we store is the book ID and the user ID. That means which ID of the book is issued to which ID of user. That means now when we have to take the data of the book, we go to circulation table, or if we want to search for who has borrowed which book, we go to circulation table, we give the user ID and we find the details of a person through user table, and then the same circulation table can give me through the book ID from the book table all the details of the documents this particular person has borrowed from the library. So this way, if you see, it is a kind of a relation among different tables which can work together and produce a system. Hierarchical model. Hierarchical model basically represents the hierarchy in which the data is stored. This given slide can show you diagrammatically the structure of employees in a university. In this slide, you can see that on the top we have the university, and in the university we have different faculties like science, humanities, commerce, and so on and so forth. Then in these faculties we have different departments which are represented by D1, D2, and so on, and each department we have actual employees. So you can see that department D1 we have employee E1 and E2 and so on and so forth. So what happens in this model, you can, when you see any entity or any object, you can find the hierarchical position of that particular object or that particular record in the whole hierarchy or in the whole map of data representation. Network model. This is a very important model. We have shown you through a diagrammatic representation of a library catalog. In this model, you can see that there are different authors like author 1, author 2 and author 3 and so on. And these authors have written several books. Now you can see in a network model that one author can write more than one book. Okay, say for example author 1 has written book 1 and book 2. Similarly, each book belongs to a particular subject. It is not necessary that book should belong to only one subject. A book can belong to more than one subject. And not only that, the authors also belong to particular subjects. And similarly, as the case of book, more than one author can belong to more than one subject. So if you see this structure, it creates a kind of a network structure for you. That is why it is called as network model. In the network model, the data can represent not only from top to bottom, the data can be represented from bottom to top. It is bit different from the hierarchical model. In hierarchical model, data can be represented only from top to bottom, whereas in network model, it can be done in both the ways. Database language. Database language is a very important aspect of any database management system, as these languages, these vocabularies help us how the database should function or how to give command to the database so that different functions can be performed over database. There are three parts of database languages. The first one is data definition language, we call it as DDL. The second one is data manipulation language, we call it as DML. And the third one is data control language, we call it as DCL. Data definition language, DDL. A DDL is basically, it gives vocabularies used for creation, modification and deletion of database. That means what it involves is how the database has to be created, then how the different fields of a database has to be created, and what are all the properties which are to be associated with each kind of field, including their data type, length of the field or the kind of values it stores. Data manipulation language. Data manipulation language is basically used for reading, writing and changing the values of the fields in the database. Basically, any kind of insertion, deletion in the database is done using through data manipulation language. Data control language, DCL. DCL basically is vocabularies used for defining user access permission and roles of users. Normally in any database management system, we have different users, and not only that, we have different levels of users with different levels of permissions associated with the users. Some users are given the privilege of system administration. That means they can delete, edit or change the structure of database. Then some users are given privilege to perform data entry tasks. So, and then there are some users who are given facility to read the data of database. So with the data control languages, we can give permission, we can create different user levels, we can give permissions to these different user levels about what activities they can perform over database. SQL commands. SQL stands for Structured Query Language. It is a kind of a database manipulation language or database language. It is a standard language used across different relational database management systems. There are different commands associated with SQL. Here we have listed some of the important commands of SQL, like there are commands how to create database, how to delete database. We have commands how to read data from fields of a table. The command is select. Then we have an insert command to add the data in a particular field. We can change the data in a table using alter command, and then we can remove the data from the fields. Similarly, we have DCL commands. uh, that means we can give permissions to certain users using grant command. We can remove privileges given to users through revoke command, and there is a command called join, which can join two tables all together and you can read the data. So the students, at the end, if we summarize this whole module, you will see that a database is nothing but it is set of structured records. A database we store normally in a kind of a software system. We call these systems as database management systems. These database management systems store information, they organize information, and we can perform search on these database management system so that information can be retrieved for a user. These searches are normally done based on keywords. The searches are also can be done based on field level. These searches are, you can say in other words, that the data can be browsed based on fields, and user can be the information can be provided to the users. We have seen different data models in this module. We have seen object oriented module, we have seen entity relationship module, we have seen the functional module of a database management system. We have also discussed in this module about the database manipulation languages we use, like database definition language, database control languages, and at the end we have also discussed about the structured query languages and some important commands of structured query language. So dear students, if we summarize this whole module of database management systems, you have seen that we have discussed about databases in the database management system. A database, as we pointed out, that it is set of structured records. We have discussed about the structure of a database. uh, then we have also discussed about database management systems. We have seen different database management systems like CDS, ISIS, MySQL, and PostgreSQL as an example of database management system. We have seen different properties of database management systems like ACID property, where we have talked about atomicity, we have talked about consistency, we have talked about isolation, and the durability of databases. We have also discussed about different data models like object based logical models and record based logical models. We have discussed about entity relationship model, we have discussed about object oriented model. We have also seen the functional model of database management system. We have also seen in record based logical models different models like relational model. We have seen the hierarchical model of data storage in a database management system, then network model of database management system. At the end, we have also discussed about database languages like database definition language, database manipulation language, and database control languages. At the end, we have taken example of different SQL commands uh, used for database manipulation as database definition language, database manipulation language, and database control language.